All right. Worksheet 1218, AB number 8. Some multiple choice problems where we can practice using our graphing calculators, which is something that we need to be very good at to take advantage of, do problems quickly, even if we can do them by hand. So I want you guys to try a couple of these. And so I want you to, try 2 and 3. Pause the video. Try those two real quick. Have your calculator out. Try those two problems on your calculator. All right, so pause the video and then try them. So number 2, if we want to do the derivative, then the fastest way, of course we could do that by hand, but fastest way would be to go math 8. Got to put this, I would treat this like a 1/5 root. Okay, so it's going to be x, you got to put parentheses, x cubed, x to the third, minus 2x, close parentheses, raised to. Then now, if you just do 1 divided by 5 like that, it will not work. It'll do raised to the 1 power, and then divide the whole answer by 5. So you got to put parentheses around it. Anytime you're raising something to an exponent that has more than just one number or one variable, you got to put parentheses around it, or you could write 0.2 if you want. So comma x comma square root of 3, and the answer is 0.902. Round truncated 3 decimal actually is the same. So math 8 in derive. We use that one a bunch. Okay. Number 3 says region R is enclosed by the graphs where K is greater than 2. The area of R is 1 square unit. Then the approximate value of K is what? What's going on here? This is an area problem. Might be good. You could try and draw a sketch. You have a graphing calculator, but still, if you don't know what the graph's going to look like, you might not get a very good graph in your graphing calculator. This has x equals plus or minus root 2 as vertical asymptotes. So square root of 2 is it's between square root of 1, square root of 4. So between 1 and 2, probably closer to 1. So maybe like 1.3. So square root of 2, negative square root of 2. As you go to infinity, it goes to 0. And negative infinity, it goes to 0 because the bottom has dominant terms. So that's your horizontal asymptote. And then you might plug in a couple values. You might say, well, if I plug 0 in there, it's going to be 0. So it can cross the horizontal asymptote. If you plug 1 in, it'd be 1 over negative 1 would be negative 1. So, and then if you plug positive 1 in, it's also going, if you plug positive 1 in, it's going to be 1 over negative 2. So I think, if you plug negative 1 in, it's going to be negative over negative 1. So it's going to be up here. And so the graph kind of goes like this. Okay. And then if you plug, let's say 2 in, or negative 2, if you plug 2 in, it's going to be 2 over 2 is 1, 2 over 2. And if you plug negative 2, it's going to be negative 2 over 2 is negative 1. So it's going to be down here. So it might go do something like this. Now, we could graph it on our graphing calculator just to make sure. But like I said, if you just graph something in a calculator and you have no idea what it's going to look like, you might you might not know what you're looking for. Should we do a negative 5 to 5, negative 10 to 10? Something to start off with. There's vertical asymptote. Say this is how my graphic calculator graphs them. It connects the two sides of the vertical asymptote. But if you didn't realize those are vertical asymptotes, you might actually think that was part of the graph. Okay, so we're looking at that, and we're looking at x equals 2, which is a vertical line, x equals 2, and we're looking at y equals 0, which is this, and the x-axis, and then we're looking at x equals k, and it says where k is greater than 2, so k is definitely to the right of 2, and we're looking at the area here, this area, and it says that the area is 1 square unit. So then what's the value of k? So what we're going to have to do is we're going to have to set this up like we're going to integrate it. 2 to k of x over x squared minus 2 dx, and it should equal 1. So now we got to integrate this. U substitution equals x squared minus 2. Du equals 2x dx. Don't want the 2. So we're going to get 1/2 integral of du over u, which is 1/2 natural log of the absolute value of u, which is 1/2 natural log of the absolute value of x squared minus 2. And then it's a definite integral, so we got to plug 2 to k equals 1. And so we plug limits in 1/2 natural log of k squared minus 2 minus 1/2 natural log of 2 squared minus 2 is 2 equals 1. So now we got to solve that equation on our graphing calculator. So the way I like to solve equations of any kind on my graphing calculator is to enter them all on one side equal to 0. So I'm going to go in here. I only graphed that earlier. So I'm going to put this in 0.5 natural log. K is bigger than 2, right? So k squared minus 2 is always going to be positive. So we don't need to put the absolute value. So we put x squared, putting x's in for the k's, minus 2, close those, minus 0.5 natural log of 2, close that, minus 1. And then where do I expect the answers to be? So I'm going to go to the window. And I'm going to, well, they're starting at 2 because x is like my k now. Going forward, I don't know, 10. I just want to see the x-intercepts, -1 to 1. Oh, you can look at the answers over here too to decide what you want your window to be. But looks like it's right there. So this is 2, 3, 4. It's like 4. Even without using my calculator to find the 0, just looking at the answers, I think it's got to be 4.1, right? So, anyways, using your calculator to get graphs, solve equations. It's a major thing you got to do. Okay, I want you guys now to try 6 and 7. 6 and 7. So pause the video, try those ones out, then unpause it, see what we get. So 6 says let f be the function. They give you function if there's a c that satisfies the mean value theorem for f prime. A closed interval, is this a continuous function? It's got to be. So the C guarantee satisfies the conclusion is this spot where the actual slope equals the average slope. But you got to find the average slope first. And the average slope is f4 minus f2 over 4 minus 2, which is going to be cosine 4 minus cosine 2 over 2. We just leave that where it is now. And then we're going to take the actual derivative, which equals negative sine x, and set it equal to the average derivative. And solve. Now, usually we isolate the trig. And then usually when we solve trig equations, they're usually these really nice values that we've memorized, but this is clearly not one of those. But we need to do it in the same way. We need to get alpha, and we need to figure out the quadrants. Now, is cosine, first thing we should do is figure out what cosine 4 minus cosine 2 is, if it's positive or negative. So cosine 4 minus cosine 2 is negative, right? So this is a positive value because of the extra negative. Okay, so that tells you you're in quadrants 1 and 2 for sine. Also, what we would usually do to find alpha, even when we use the nice memorized angles, is we ignore the negative first. And we really want to do that also in our calculator to make sure it gives us quadrant 1 alpha. So I'm going to do inverse sine of, and we want this to come out positive, so I guess we could either take the negative of the previous answer divided by 2, and this should give you 0.119029. That's alpha, but it's in quadrants 1 and 2. So you got to be careful. A lot of people are going to automatically pick A, which is the wrong answer because it's supposed to be, remember the guarantee, the mean value theorem has to be between the endpoints. So algebraically, we're going to get maybe more answers. So quadrant 1 would be x equals 0.119029 plus 2 pi k. And quadrant 2 would be pi minus alpha plus 2 pi k. So we got to look at, well, what are all the different possible answers? So we got 0.119, but then we could also add 2 pi to that, and we get 6.402. Well, that's too big. So let's try the quadrant 2 answer. So pi minus 0.119029 is 3.022. And that one is between, and we could get other answers, 9.305, but 3.023 if you round it. So one of the things you got to watch out for on your calculator is when you solve trig equations, it's going to give you principal values. And the way to make sure you don't have to memorize what principal values are, mostly, is to force it to give you quadrant 1 angle, which is alpha, and do it the same way you do it without a calculator for nice angles that you memorized. So be careful. Let's see. Number 7, slope of line containing the point 40, and tangent to this graph is what? The slope of the line. So we're trying to find the slope of a line connecting this to the tangent of the graph. Okay, so what does this graph look like? Well, e to the x looks like that. Negative e to the x looks like this, right? So that's the graph. And then there's this point 1, 2, 3, 4, 0 that connects a tangent line. Now, this graph has an infinite number of different tangent lines, but I think there's probably only one tangent line that will also go through this point. And it would be kind of like this, right? I think a picture is very helpful here, right? So we're trying to find the slope of this line. Now, to find the slope of this line, I think we have to figure out, well, where is this tangent to? Now, I'm just randomly kind of putting it there, but we got to figure out, well, where is this happening? You know, because once we figure out where this is happening, then we can get the slope of the tangent line by just taking the derivative of this, right? Y prime equals negative e to the negative x. So once we have the x, then we'll be good. So how do we find the slope? Slope equals rise over run. So I'm going to call this one xy, and this one was 4, 0. I'm going to say, all right, well, rise y minus 0 over x minus 4. That gives you the slope of the line, right? And for us, the y coordinate here is going to be the y coordinate of this curve. So we could plug this expression in for y. This one's kind of a tricky problem. So we're going to get e to the negative x minus 0 over x minus 4. So that's the slope at that point x. But we also know that it's supposed to equal this equation, negative e to the negative x. And so now we could use that to solve for x. So this is a tricky problem. So we could divide e to the negative x out of both sides, right? We could flip both sides upside down, add 4 to both sides, and the x value is 3. And then we could plug that back in to our derivative equation, or even the one we wrote there, that expression, and figure out what that is on our calculator. So let's see. Negative 1 divided by e to the 3 is negative 0.0497. And if you round it 3 decimal places, you get negative 0.050. So it's an interesting problem. I don't know if the calculator helped us a ton on that other than get a decimal answer. Let's go to the back. Try a couple problems on the back side of this worksheet. Which one should we do? Let's see. Let's do, I don't know. Let's do 9 and 11. Let's try those first. Those look like good ones. We'll just try those first. 9 and 11. So pause video. Try 9. Try 11. Okay, 9 says a 6-foot ladder. So a ladder leaning against a vertical wall. The tip of the ladder is sliding down the wall at a rate of 5.6 feet per second. What is the rate of change in radians per second of the angle at the instant when the tip of the ladder is 7 feet above the ground? So this seems like a related rates problem, right? Because we want dr d theta, right? And then this is change of this length right here. So we probably got to create some variables. I mean, we call this one x, we call this one y, we call this one z if you want. So this would be like, and this would be dy dt. If I call this y, then as y changes, as the ladder slips down, then y is, but I got to put a negative on here because y is getting shorter. X is getting bigger because this is moving outwards. Z is staying the same, right? Z dt equals 0. But then there's a rate change for the angle. Now, first of all, do you think it's positive or negative? Is the angle getting smaller or bigger as the ladder slides down the wall? Smaller. So we definitely should get a negative answer. And if you look at all the answers, they're all negative. But it's always good to do that, especially in free response. So what's the way we relate y with theta? Well, we could use sine or cosine or tangent. Any of those will work. I think the easiest one would be the one that involves y and z, because z isn't changing, so that seems like a convenient one. So I'm going to go with sine. Sine of theta equals opposite over hypotenuse. Now, one of the things that we can do on related rates problems is plug any constants in before we take the derivative. So z is always 16. Y is not always 7. So don't plug 7 in for the y yet. That'll mess it up. Now, if you leave the z as z in there, it'll work out in the end, but it'll just be extra messy. But this makes this derivative way easier because we were going to have to do quotient rule. Now it's just a constant. So the derivative sign is cosine theta. And then you got to do implicit differentiation because we're taking the derivative with respect to time. So you need d theta dt, which, by the way, is what we're looking for, d theta dt. equals 1/16 dy dt. Okay, so d theta dt equals 1/16 dy dt is negative 5.6, right? And then we got to divide by cosine. Now, cosine of theta is adjacent over hypotenuse. So we do need to figure out what x is. So we need Pythagorean Theorem, I think x squared plus y squared equals z squared. And so x squared plus 49 equals 16 squared, 256. 6 squared 3, 9, 0, 6, 1, 6, 15, 256. 256 minus 49 gives you x squared equals 60 minus 9 is 7,207. Is that right? It's kind of an ugly number. Okay. So square root. So that's going to be square root of 207. So that should be our answer. We plug that in our calculator. I guess this is the one place the calculators come in handy. Negative 5.6 divided by 16 times 16 divided by the square root of 207. And we get negative 0.389. Now, they've rounded all their answers or truncated to the nearest tenth. So our answer would be C. 11. Spherical tank contains 81.67 gallons of water at time 0. For the next 6 minutes, water flows out of the tank at a rate of 9 sine squared root of t plus 1 gallons per minute. How many gallons of water are in the tank at the end of the 6 minutes? This might sound like relay rates, but it's not. I mean, it has rates, and it has time, it has geometry, but this is a rate model, right? Rate model. But a simple rate model because all we have is a rate coming in, not a rate coming out. So the idea is that the amount is going to equal the known amount at some time, which is 0, plus the amount of everything that's come in from 0 to t of the incoming rate. And if there were outgoing rate, we do minus that one. So this is 81.637. And so if we want A at 6 minutes, it's going to be 81.637 plus 0 to 6 of 9 sine square root of t plus 1 dt. And this is also an idea of like a fundamental theorem of calculus part 1. If you integrate the rate, you get the difference in the amounts. So let's do 81.637 plus math 9 of 9 sine square root of x plus 1 close comma x comma 0 comma 6. Oops, mess something up. Now I don't want to retype it all. Math int 9. Oh, I forgot to close the parentheses on the sign. So I get 126.668. There you go. Let's see. Okay, I want you guys to try 12 and 13. So pause the video, try them, figure out how you can use your graphing calculator to help you. First derivative, so they're giving you f prime, and they say how many inflection points does it have? Now, what we can do is we can put this equation in our graphing calculator, but what I think the easiest way, and we could find the second derivative by hand, but if we want to make this easier, let's enter the second derivative in as another equation. Now, a lot of times I actually use this down here at 0. So I don't know if you guys still have this in your calculator. If you go here, I'm going to put this one in. x minus 4e to the negative sine 2x, close. And then there's this, I usually leave it down here in the bottom, and I don't have it here. But what I like to do is I like to trick my calculator into graphing the derivative of this graph. So my calculator isn't really good at finding derivatives like formulas for them. It's good at calculating derivatives at a single point, but I could get it to calculate at like a ton of points and draw a graph that I can actually analyze. So what I'm going to do is I'm going to down here in y0 go math a and derive and tell it vars y vars function y1 comma x. So you always have to say what you want to take derivative of, and then usually you put the number, the value you want, but I'm going to say it x. And what that's going to do is it's going to calculate all the derivatives in the x window from my window and graph them. And so this is kind of a cool trick. Now I'm going to go up here and turn this one off so it doesn't graph it at the same time. It'll still access it. So even if you turn it off, it knows to do the derivative of it. And so then I'm looking at my window. It should be 0 to 2 pi. They said on 0 to 2 pi. And then I'm going to do, now you got to be careful if you do zoom fit, that can backfire sometimes if the graph is really big. Let's see what happens. And you should be able to tell right away if it's graphing like a super zoomed out version by the like the y-axis might look really dense. That's not too bad. So there it is. I think that's reasonable. So what it is I've tricked it into graphing the second derivative graph. And so then this is an inflection point because it goes from positive concave up, because this is the second derivative graph, to negative concave down, to positive concave up, to negative concave down. And so inflection points are wherever the concavity changes sign. So here, 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 and here. And all we were asked to do is identify how many. So we don't even have to solve. So kind of a nice way of tricking your calculator and do something, make it quicker. 13 says a particle moves along the x-axis. So it's velocity, time greater 0. So they give you velocity, time has to be greater than equal 0. At time 0, the particle's at position 1. So x0 is 1. What is the total distance traveled by the particle from 0 to 4? Total distance is different than displacement. It's the integral of speed, which is the integral of the absolute value of velocity. Okay, from 0 to 4. And if we had to integrate that by hand, it would be a bit of work to try and integrate that absolute value, because we'd have to figure out where to break it up and where to fix it. But now on this last problem, I'd probably turn this guy off. If you want to leave it there, that's cool, but turn it off. But I could do Math 9, and I can go to the Math menu under Num and select ABS and type the equation in 5x e to the negative x minus 1 before I close the absolute values. Close the absolute values, comma x, comma 0, comma 4. So by hand, this would be a lot of work, but with a calculator, it can integrate absolute values very nicely for you. So I just got to patiently wait, take a deep breath while I enjoy my time off. 1.821. Way easier than doing it by hand, for sure. Why don't we try 15? Okay, so 15, they give you a function, they call it capital F is the integral, and they want to know what f prime of 0.5 is. So f prime means that we're going to have to take the derivative of an integral, right? Not that you have to write it like this, but And derivatives undo integrals. And then you got to plug the limit in, but you also got to plug in the bottom limit. And then you have to multiply by the derivative of what you plugged in. So that goes away. So f prime of x by the fundamental theorem of calculus part 2 is just the square root of tangent x. So f prime of 0.5 is going to be the square root of tangent of 0.5. Make sure you're in radian mode, and that should be your answer. Square root of tangent of 0.5, close, 0.739. 0.739. So, all right, there's one more worksheet I'll do in a separate video, but there's a few problems on here you got to finish yourself. Hopefully that was a good review of how to take advantage of your graphing calculator.